pull up on the internet. I'm going to pull up Pascal's triangle. Okay, so what we're trying to do is we're trying to expand out the ninth round. Okay, so I'm going to look down. The ninth round is this guy here, where we have 1, 9, 36, 84, 126, 126, 84. Okay, so I'm going to use the triangle to expand this thing out. Okay, so I'm not going to have this up while I do it, but you guys, I encourage you to pull it up. You could just Google Pascal's triangle, or you can use the one on Classroom, just to kind of see how I'm using it as we go. So if I'm going back here, let's go back into example 1. I am going to use that triangle to expand this guy out. Okay, so I know before I do anything else, since this is just a C and a D and this is an addition, okay, and this is a little bit dangerous to do, just because if this changes to a subtraction sign, or if there's a number out in front of this, you can't just go ahead and you can't go forward and do exactly what I'm doing here, or if this is a number instead of a variable. But essentially what happens is this first term, C, starts with the ninth power, right? And then everything goes, I'll just make a couple of these guys. Everything goes down from there with the C's. So C to the 8th would be next, and then C to the 7th, and notice it's just this term to a lower power, right? So if that's a number, it would be, a number to a lower term. Anyway, C to the 6th. Then I would have, if I keep going here, C to the 5th plus C to the 4th plus, and notice this gets pretty long, C to the 3rd plus C squared plus C plus no C at all. And the last one, it would just be D to the 9th. So now for the D's, we start out with no D's, right? We essentially have D to the 0th, which is just 1 here, okay? To keep the pattern going, we need that, but it's just a 1. Here, this would be C to the 8th, D to the 1st, which was just D. Our next term would just be D squared. So these are going up as we go. So D, since the second term is going up a power each time. Notice that the combination of powers is always equal to 9, right? 8 plus 1 is 9, 7 plus 2, 6 plus 3. Then we have D to the 4th, D to the 5th, D to the 6th, D to the 7th, D to the 8th. And then the last term is D to the 9th. Okay, so now I can use Pascal's triangle to just plug in my coefficients, which is awesome. So if you pull up that triangle and you look at that 9th row, the 9th row is 1, which we don't have to write because it's in front of that thing, but we have 1, then we have 9, then we have 36, then we have 84, then we have 126, and then again we have 126. Okay, because we have 5, 4, 4, 5. And then we have 84 again, so notice this just goes backwards now, then 36, and then 9, and then 1 again. Okay, so that's using the triangle to expand one of these out. So that's like if you took C plus D and you multiplied it by C plus D, C plus D, and you did that out 9 times and you FOILed it all out, this is what you get. Okay, so this is a big shortcut to doing that kind of work. So that's using the triangle. Now, on the test, you can use the triangle to check your answer, but I'm going to be looking for your work. So I'm going to teach you the binomial theorem, which is how this pattern is built. So to figure this out, we're going to go back to our sum notation. Okay, so the sum of some pattern going to n, where we start with k equals 0. Okay, that's like the first round in the triangle. The coefficient is always going to be this. It's going to be n factorial, which we'll talk about, over k factorial, and then n minus k factorial. Okay, if this is talking about some term a and b that's being expanded out, then we will have a to the power of n minus k. Okay, so notice if I'm going to 9, that'll be like 9 minus 0 is what we'd start with, right? So it would just be 9, so a to the 9th. And then we would have b, the second variable, would be to the k power. Okay, so we always start with k equals 0 and we go to whatever n is, okay, to figure this out. This is a little bit confusing looking at this, but just wait, you'll see the pattern. It's not too bad. I'll refer to this often. Okay, so for example 2, and we're only going to do example 2 and that's it. All right, guys, so let's do this out. We're going to expand out x plus y to the 10th using the binomial theorem. Okay, so yes, we could use Pascal's triangle for this, but we're just going to use the binomial theorem so you know how to show work for this. Okay, so to figure this out, since I have x plus y, I mean, I guess I'll teach this one a little bit different, but you guys know the pattern, right? So we're going to start with x to the 10th, and then we're going to drop down x to the 9, 8, 7, 6, 5, 4, 3, 2, 1. Y starts with 0, then go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But let's figure this out. So to figure this out, what I need to do is to figure out the coefficient that is in front. I am going to start with, so I'm going to use this factorial language. Now again, a factorial, you guys, if I have like 5 factorial, that's the same thing as writing like 5 times 4 times 3 times 2 times 1, okay? That's what a factorial is just saying, okay, all numbers starting with 5 multiplying by a number lower each time, and then we add up the total, okay? So that's what a factorial is. So here, for this one, to figure out the coefficient in front, it's going to be, the first round is going to be 10 factorial over, okay, now notice, it's k, which we always start with 0, right? So 0 factorial, and then the total minus whatever that thing was. So 10 minus 0 is 10 factorial. Okay, so what ends up happening here, what this looks like, and I'm going to erase this shortly after I did it, but this would be like 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over. But notice here, we have another 10 factorial, so we'd have another one of those, right? So 10 times 9 times 8 times 7, I'm not going to write it all out. 0 factorial is just equal to 1, right? So we have an extra 1 in there. But look, everything cancels. And if 0 factorial is equal to 1, then it doesn't really matter when we're talking about multiplication. So when we have the first term here, 10 factorial over 10 factorial, we essentially get 1. Okay, so that's my coefficient for my first term. Okay, so the first term would just be 1. We don't need to put the 1. Then, to find the second one, okay, so to find what power we have for x, which we already know the pattern, the x power is just going to be taking the total amount of powers that we have, right, which it's n, minus the k value that we're on. So we're on 0 right now. So I'm going to take the first variable to the 10th power, and then I technically also have the second variable to the 0th power. Okay, but that's just equal to 1, so I don't include it. All right, so my first term is just x to the 10th. All right, so now I'm going to make some room here. So I want you to show your work when you guys are doing this, and I know it's going to take a little bit of time and effort, but you only have a couple problems. Okay, so to find my next one, it's going to be 10 factorial. So now this is round 0, this is round 1 now. Okay, so now I'm going to be, my k value is 1, so it's going to be 1 factorial, and then 10 minus 1, which is 9 factorial. So notice, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then 9 times 8 times 7, 6 times 5 times 4 times 3 times 2 times 1, that all cancels, right? So what I'm left with is, so just to be clear, I have all of this, right, over 1 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. These all cancel, right? All of these cancel, and I'm left with 10 over 1, which is 10. So my coefficient is 10, okay? Then I'm going to take my first term, right? And again, the first term is always going to be equal to n minus k. In this case, k is 1. So it'll be x to the 9th and y to the 1st. This power here is always related to this number right here, the first iteration. Okay, so that's that one. For my next one, okay, I'm going to do 10 factorial over 2 factorial, 8 factorial. The 8's cancel, and I'm left with 10 times 9 over 2 times 1, which is 90 divided by 2, which is 45. So my next coefficient is 45. I'll have x to the 8th y squared. All right, and again, it's just this term to the 8th power, this term to the 2nd power, because I'm on the 2nd round here. 0, 1, 2. Okay, the next one will be 10 factorial over 3 factorial, 7 factorial. The 7's all cancel, so I'm left with 10 times 9 times 8. Okay, this canceled with the rest of it, over 3 times 2 times 1. Okay, so this is equal to, and I'll have to get a calculator out here soon to start doing these, but this is equal to, let's see, 90 times 8, which is 720, divided by 6, which is 120. Okay, so you have 120, x to the 7th, y to the 3rd. Okay, then you move on to the next one. Okay, the next one would be 10 factorial over 4 factorial. Okay, we're now done with the 3rd. We're on the 4th round. 4th factorial, 6 factorial. Everything cancels except for like up to 6. So we have 10, 9, 8, 7 over 4 times 3 times 2 times 1. Okay, so 10 times 9 times 8 times 7 is 90 times 8 times 7, which is 5,040. And then we'll divide that by 4 times 3 times 2, which is what, 24? So we'll divide by 24, and we get 210. Okay, so when you do that, you get 210. So you have 210 x to the 6th, y to the 4th. All right, and then we keep cruising. So I'm going to make some room here. I did give you guys a little bit of space on the homework sheets. You might need a little bit more right small when you're doing these. Okay, so now we're on to the next round 5 now. Okay, so we have 10 factorial over. Okay, so again, if you get lost, okay, so right now I just had to take a second to like say, okay, where am I? Remember your rule here. So K tells you the round that you're on, right? So we're on the 5th round, so it's going to be 5 factorial, 5 factorial. The 5's cancel, so this essentially is 10 times 9 times 8 times 7 times 6 over 5 times 4 times 3 times 2 times 1. The 5 and the other 5 from this 10 factorial, those canceled. So now I just have this 5 factorial, which is 5, 4, 3, 2, 1. And then I have 10 through 6, right? So multiply that out. So you have 10 times 9 times 8 times 7 times 6, which is 30,240. Okay. Then you're going to divide that by, this is 20 times 6, which is 120, divided by 120. And you get 252. So it's 252 x to the 5th, y to the 5th. Now what I want you to see here is what happens after this. This is for the nice ones, and I'm only going to give you kind of nicer ones on the test. So notice, the next piece to this puzzle is round 6. So round 6 is going to be x to the 4th power, y to the 6th power. Well, we already did one like that, right? We did this guy right here. So I actually know, since there's no numbers out in front of these guys and they're just variables, that when I do this again and I plug the factorial in, I'm going to get 210. And to show you that here, this will be 10 factorial over 4 factorial, 6 factorial. The 6, 5, 4, 3, 2, 1 cancel, and you're just left with 10 times 9 times 8 times 7 over 4 times 3 times 2 times 1, which should be familiar to you if you're paying attention. You get 210, right? So that one comes back around. Then your next one would be x to the 3rd, y to the 7th. Well, that lines up with this guy, so 120. Okay, so there's a shortcut here. So I need you to show work at least to the halfway point. If there's numbers or anything else other than variables in here, though, things will change, and signs could change and that kind of thing. So just be careful doing it this way. So the next thing would be 45 x to the second power, y to the 8th. Notice these just swapped. Then we have 10 to the 10 times x times y to the 9th. And then we're going to finally add y to the 10th power. So there you have it. We've expanded using the binomial theorem, x plus y to the 10th. I don't think in the homework I make you go to the 10th. I think the most I make you go to is like the 6th maybe. And on the test it'll be very similar. I won't have you spend a ton of time doing this. So they should be a lot easier than this. This is kind of a harder one. The last thing that I'll say is be careful of signs. If you have x minus y to the 10th, right? Then notice that the numbers, the signs in between could change, right? So if you were to do this one out, you would have the coefficients would be similar, right? So we would still have a similar coefficient because we're still finding the coefficient out in front using the same method. But then we have what you have to be careful of, and I don't think they'll give you one like this. I think it'll be one like that's like a x minus 6 or something like that, is if you have negative 6 to an odd power, right? So if you take negative 6 to like the first power, for instance, you're left with negative 6, okay? So be careful there. That negative 6 then would be multiplied by the number out in front, right? So I'm happy to work one of those subtraction problems with you probably in class together, but that should be enough to get you started on most of your homework.